is a remainder. So a remainder is what you get when you divide a number that's not a factor. So for example, if I were to divide 3 into 17, what would be my remainder? 2. Because 3 can go into 17 5 times. So that would give me a 2, a remainder of 2. So now we're trying to figure out if I were to divide this function by these factors, what would be my remainder? It's called the remainder theorem. So I'll give you a moment, and then we will work through those. Okay, so you can kind of see your skills check. That kind of helps you with the quiz next week, because there is quite a bit of limits on the quiz. So, all right, so it's actually very simple. This is actually a very, very simple problem. What the theorem says, which is not so important, is that if I want to know what my remainder is, if I divide it by a factor, I just need to substitute what that 0 would be in the function. So what that means is if this is the factor and I set that equal to 0, what would I get? 3. So I need to find f of 3. If I substitute 3 into this function, whatever number I get, that is the remainder. That is the numerical remainder that I would get if I were to actually divide it. And we will be doing synthetic division tomorrow. Hopefully you remember. If not, I'll remind you. So go ahead and pick up your calculators, type that in, see what you get. What would be your remainder? It should be a number. So what did you all get when you substituted in the 3? Negative. Okay, let me check my answer key real quick. See if I agree. Negative 14. That's what I got. I got negative 14. So that would be my remainder. Good. All right, so what am I going to substitute in if that's the factor I'm dividing? Negative 2. So let's go ahead and do that. Now, whenever you're substituting in the negative, remember, you have to put that exponent on the outside. It's very important that you substitute it in correct. So I'll give you a moment to copy that, to type that in your calculator, see what you get. Okay. Okay. So what did you all get? Negative who? Oh yeah, that's what I got too. Sorry, I don't know what I was thinking. Okay, let's move on to example 2. So go ahead and do both of these. Now we have a different function. But again, to figure out the remainder, if I divide by these factors, so I'll give you a couple minutes to work through both of those, and then I'll put up my answer shortly. For the homework, if you're not showing your work, you're not going to get credit. I just want to be clear. Like, just the answers doesn't really show how you got the work. So, I mean, I am aware of some of the things that's available, like AI. I mean, AI is everywhere. Photo math. So if it doesn't look like you actually work through it, just kind of know. So you're doing 2 substitutions. So I'm gonna freeze my screen and write what I got. Oops. Okay. So especially for this one, because I think that's where we kind of went wrong on some of these questions yesterday. It is so important. Notice that, and there's also a difference in your calculator. The calculator differentiates subtraction with the negative. So I know in one of my other classes, she put a negative where it was a subtraction. So you have to be very, careful as you're typing it in to make sure that you're getting that. Why did I put a 2 at the end? Oh, okay. I'll say that's weird. I don't know. So -3 in every place. Use your parentheses. So I'll give you a moment to do that. And for the next one, it should be -1. And then I did the same thing for this one. I put a -3. I don't know what I'm trying to do. Like, I'm not making any sense. Okay. So when you have your 2 remainders, you can put your pencils down. One of them should be 0. And the other one, I got a big number, like over 100. All right, so for the first one, I got +130. Anyone else get that? 130? That would be my remainder. If I divide x plus 3 into this function, the remainder I would have at the end is 130. For the second one, I got 0. Does anyone know what that means whenever you get a remainder of 0? Yeah, dear. What'd you say? True, but when would you not have a remainder, Maya? If it's a factor. What this tells me, if you have a remainder of 0, that this x plus 1 is a factor. Remember, every polynomial is made up of different factors. So when I say factor, is one of the polynomials that we would have to multiply to get to that. So x plus 1 is one of my 4 factors, or one of the factors, because it may not be 4 factors. All right, so with that in mind, I want you to do the remainder test to figure out, well, the factor test to figure out if this is my factor, if that is a factor of this function. You would have to find f of positive 1 to see what you get. If you get 0, it is a factor. If you get anything other than 0, it is not a factor. So this is your polynomial, and this is the factor we are testing. So go ahead, take a moment and do both of those. This one is a long one. 3x to the 4th minus 3 to the 3rd. Oh, okay. I don't think I'm really reading well today. I'm not really sure, but I'm struggling in my reading. Okay. And what are we trying to look for whenever we do the factor test? What answer are we looking for? 0. Good job. So I'll give you a moment to work through those. And then that's a yes or no question. Either yes, it's a factor, no, it's not. So for the homework, there's a couple questions where you're just trying to find the first remainder. And then there's a question where you have to figure out if it's a factor. And you all know how to put a fourth degree in a calculator, right? I should probably have asked that a long time ago. Anybody need help with that? How to put in a fourth degree? Okay. So for the first one, you got yes, right? Because you should have ended with a 0, which means yes, this is a factor. For the second one, you should have got -4. Who got -4? So because we get -4, this means that x minus 2 is not a factor. So yesterday, everything we did, we could factor easily. We could take out a GCF and we could factor it down. But now we're going to look at polynomials that cannot be factored. And we still have to find all of the solutions for that polynomial, okay? So we're going to do a lot of synthetic division to test numbers, but we need to know what numbers to test. What are the possibilities? So go ahead and write this down. Just this part is really important. It's the P over Q test, which means that the possibilities, this doesn't mean that they are, but my possibilities are all of the factors of my constant divided by all of the factors of the leading coefficient. So my constant, we call that P, the leading coefficient Q. So it's the P over Q test. So in looking at your homework for this assignment, I shortened it quite a bit. It's only 6 questions. Just make sure you're reading the directions, because the first 2, you have to do the factor test. And then number 41, you only have to list the possibilities. So the actual solving are the last 3 questions. But we have to know what numbers to even try. Because if that 0 is not a possibility, we don't want to waste our time doing a test on something that's not even a possibility. Bless you. So the possible zeros, you take the factors of your constant term and divide that by all of the factors of your leading coefficient. So for this example, P is 25. You ignore the sign. My leading coefficient is 1, which is Q. So my possible zeros, the possible, these doesn't mean that they're the actual, but they're the possible. All right, so what are the factors of 25? So we always know 1, right? 1 is going to be one of our possibles for everything, okay? 1, what else? 5 and 25. So those are my only factors for 25. Q only has 1 factor, which is 1. So I have to take these 3 numbers and divide it by Q. So I only have 3 possible. Well, not 3, I have 6. All right. So every single term could be positive or negative. Now, you don't have to put a plus and minus in front of all of them. So I usually just put my plus minus in the front. So you don't have to list a plus minus, before each one. Usually, I just put my plus minus in the front, and it just counts for everything. So there are 6 possible rational zeros. So if I were to graph this on a graphing calculator, there's only It's not going to cross at 3. It's not going to cross the x-axis at 4. It's not going to cross the x-axis at 7. It's going to cross at either +1, -1, +5 or -5, or +25 or -25. It's going to be one of those possibilities. And then later on, I don't know if we'll get to it today. We might get to it today. We will actually practice finding what those zeros are. All right, any questions? All right, let's do another one. Go ahead and just copy down this function here. And then we'll do our P over Q test. So I have to list all the factors of 6 and all of the factors of 2. So what are my factors of 6? We know we got 1. What else? 2, 3, 6. 2 only has 1 and 2. All right, so now I'm going to have some fractions that are possibilities. So plus or minus, I'm going to take all 4 of these numbers and I'm going to divide them by 1, which is going to give me the same 4 numbers. So I have possibility of plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 6. Now let's go back and divide these 4 numbers by 2. So 1 over 2 is also a possibility. So 1/2. When you take the 2 and divide that by 2, what's 2 divided by 2? 1. We already got that. We don't have to list that again. And then we have plus or minus 3 over 2. And then when you take the 6 and divide that by 2, what do you get? 3, and that's already listed. So this counts for 2, 4, 6, 8, 10, 12 different possibilities. Again, make sure you're reading the directions when you take the quiz next week. If it says only list the possibilities, that means you're not solving it. Don't waste your time solving something that you're not asked to solve. All I want you to do is tell me the possibilities. So we got one more, and then I think we're ready to actually work through a whole example. All right, go ahead and do this one on your own. P over Q. Find all of your possibilities. I'm going to freeze my screen and do it myself. And then I'll show you what I got. Yeah. So if you do it correctly, you should have you should have 6, which means in actuality you have 12. So you should come up with 6 distinct numbers. That would be your possibilities. 4 of them are fractions, 2 of them are whole numbers. Who's found all 6 numbers? Anybody still working on it? Okay. All right, so this is what I came up with. So first you start by dividing these numbers by 1. So that's how I got the 1 and the 5. Then I took the 1 and 5 and divided them by 2. So that gave me 1/2 and 5/2. Then I took the 1 and 5 and divided them by 5. Now that only gave me one new one, because 1 over 5 is 1/5, but 5 over 5 is 1. We already had that. So that only gave me one new potential. And then lastly, I took the 1 and 5 and divided it by 10. So that gave me 1 over 10, but 5 over 10 is the same as 1/2. So there were, remember, every single last one of these is positive or negative. So there's 2, 4, 6, 8, 10, 12 different possibilities. Any questions? All right, we got one more and then we'll be finished for today. Tomorrow we're going to finish a little earlier, so you will have time to work on homework, because there is, quite a bit of homework. All right, so let's look at number 7. Now we're going to figure out what they are. So we have a function, and that function is 3x cubed plus 4x squared minus 17x minus 6. Now it's a 3rd degree, so we only need to find 1 0, and that's going to knock it down to a quadratic. And we have other methods to solve a quadratic. We can factor it or use the quadratic formula. So the first thing is, how many zeros am I looking for? If it's a 3rd degree, that means I'm looking for 3 answers. I'm looking for 3 answers because it's a 3rd degree. So now let's figure out what are our possibilities. Okay, we don't want to waste time doing synthetic division on numbers that we know won't work. So my factors of 6 are 1, 2, 3, and 6. I need to divide that by 1 and 3. So that's going to give me plus or minus 1, 2, 3, 6. And then I have 1 over 3, which is new, 2 over 3, which is new, 3 over 3, which is 1, and 6 over 3, which is 2, and we already have that. So these are my possible roots. All right, who remembers how to do synthetic division? That's where you just add and multiply. All right, let's do it. So I'm going to start testing these. My goal is to figure, now you have 2 different ways you could do this. You could go in and substitute to see which one is going to give you a 0. But if you do that, you're still going to have to go back and do synthetic division. So let's do synthetic division. We're going to start testing. Always start with 1. And then you only list, remember, for this method, you only list your coefficients across the top. So for synthetic, we just bring down that first number. And then you take the 1 times 3, you put that under the next number. And then you add. All right, so we're going to take 1 times 3, which is 3. Put that 3 here. Add. What's 4 plus 3? And I'm going to take 1 times 7, which is 7. Put that here. When you add, you get negative 10. And then I'm going to take 1 times negative 10, which is negative 10. I do not end with a 0. So that means that 1 is not, that's not my answer. So let's move on and do it again with negative 1. Let's test negative 1. Same process. So we need to find one that's going to work before we can move forward. So I'm going to bring down the 3. Negative 1 times 3 would be a negative 3. Add, you have 1. 1 times negative 1 is negative 1. I can already tell this is not going to end favorably. So that didn't work either. So it's not 1, it's not negative 1. So what's going to be the next possible 0 that we test? 2. Let's do 2. So I'm going to do it again. Put the 2. List your 4 coefficients across the top. Bring down the first number, 3. 2 times 3 is 6. Put that here. What's 4 plus 6? 10. 2 times 10 is what? What do you get when you add? Negative 17 plus 20. 3. Call him back. 2 times 3 is... Okay, look at that. We got a 0. So we got one of our answers. So I'm going to go back over here. I figured out one of my answers is 2. And we'll finish this tomorrow, but what I'm going to say is that this represents your A, B, and C. So we would then have to factor this down. 3x squared plus 10x plus 3 to get my last 2 answers.